Earth's surface is close to 200 million square miles in total, with a circumference of over 24,000 miles at the equator and a population nearing 8 billion. As big as this might sound to humans, however, it's absolutely nothing in the grand scheme of things. The universe is incomprehensibly vast, and there's no clear consensus on exactly how far it stretches. This is Unveiled, and today we're answering the extraordinary question, how big is the universe really? Do you need the big questions answered? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one, and ring the bell for more thought-provoking content. Before getting into the size of the universe, it's useful to first think about the age of the universe. Surprisingly, we didn't have a really accurate estimate for the universe's age until the 2010s. Thanks to data gathered by the Planck Space Observatory, we now know today that the universe is roughly 13.8 billion years old, give or take about 20 million years. We got this number by studying the universe's rate of expansion and the cosmic microwave background radiation, or CMB, the residual radiation left over by the Big Bang. The CMB dates to around 380,000 years after the Big Bang, just as particles began forming atoms. But you'd be wrong in assuming that because the universe is 13.8 billion years old, the observable universe can only reach 13.8 billion years in any direction, which would give the universe a total diameter of about 28 billion light-years. In fact, scientists have found that the observable universe is a lot larger than that, with a diameter of around 93 billion light-years. This means we have an observable universe that is far larger than seems possible. But there are a few reasons why this is the case. The biggest reason is cosmic expansion, as the space between spaces grows at an increasing rate. There is, however, a contentious theory among a small group of scientists that, contrary to what Einstein's theories outline, suggests the speed of light is not a constant. These scientists have been arguing since the 1990s that the speed of light was once significantly faster and is in fact slowing down. And it is true that at 186,000 miles per second, the speed of light is pretty slow relative to the size of the universe. That's still a niche theory, however, and the most widely accepted explanation for this phenomenon is still cosmic expansion. The universe sprang from the initial singularity at the dawn of time, the point of infinite heat, matter, and density from which everything in existence came. Since the Big Bang, the universe has been expanding. However, for a long time, we believed that the rate of expansion was slowing down. This isn't actually the case at all. In 1998, studies that measured the distance to two large supernovae found, shockingly, that cosmic expansion is accelerating. These supernovae were, and still are, moving away from us and from each other increasingly quickly. The way we know things are moving away from us here is redshift. Essentially, because red wavelengths of light are longer with lower frequency than blue wavelengths of light, the longer wavelengths are the ones able to reach us as an object moves further away. This means objects visually appear redder and redder. Redshift is invaluable in calculating distances and speeds. And it's important to note we do have some estimates of how fast cosmic expansion is happening, too. And interestingly, it's probably happening faster than the speed of light. One estimate puts the speed of inflation at 68 kilometers a second per megaparsec, with a megaparsec being over 3 million light-years. That makes expansion a lot faster than the speed of light, but it doesn't break the idea that nothing can travel faster than the speed of light because it doesn't refer to an object moving through space. The expansion of space is the reason the observable universe has grown to be 93 billion light-years from one edge to the other. It's important to note that observable extends beyond the visible universe, which is what's currently visible based on our eyes and instruments. There are things way beyond the range of our perception that still constitute the observable universe, because they're the areas that the light from the Big Bang has reached. However, while we do know more or less how big the observable universe is, the unobservable universe is an entirely different story. In truth, we just don't know how big the unobservable universe is, but we can make some solid guesses based on what shape the universe might be. Specifically, though we can't know for sure, the most likely possibility is that the universe is mostly flat but slightly curved. The degree the universe is curved is minuscule, but it doesn't mean there's a limit to how big the universe can be until it literally comes full circle. If the laws of physics beyond the boundaries of the observable universe are the same as the laws within it, and we have no real reason to believe that they wouldn't be, then that would make the universe around 23 trillion light-years across. If the universe doesn't have this degree of curvature, then it could potentially be an infinite flat plane, or it could be a closed sphere the size of which we have no frame of reference to estimate. But it is true that many complex phenomena in the universe are flat. The solar system, for example, is a mostly flat plane, as are galaxies. So it's not too difficult to imagine that the universe itself also occupies a flat shape in a way. In a lot of ways, humanity is still at the very beginning of our cosmological journey. The Planck spacecraft, responsible for many of the findings any calculation of the universe scale relies on, did only start working in 2009, shockingly recently. And we've come leaps and bounds because of it in our understanding of the universe. Only 100 years ago did we work out how to calculate the distances between stars by examining how bright they were, a technique pioneered by the American astronomer Henrietta Leavitt. Her calculations gave us the standard candle model, where we can extrapolate distances by looking at light sources. Often the light sources used are incredibly bright supernovae. This is still the cornerstone of our methods to work out the vast distances of outer space, and we had no idea about it until the early 1900s. To come so far since then, to construct a spacecraft as advanced as Planck, and be able to image and observe the cosmic background radiation of the entire universe is an astonishing feat. Now we know that there are an estimated 200 billion stars in the Milky Way, and we know how far away we are from the galactic center. We even know that our closest neighboring galaxy, Andromeda, is on a collision course for us. None of these calculations were possible just a few decades ago. Ultimately, we may never know the true size of the universe because it's always growing at an alarming rate. It's not yet clear what the endpoint of cosmic inflation will be, as the universe progressively becomes almost entirely made of dark energy while its entropy increases. Cosmic inflation might one day slow down, but it probably won't, leaving Earth even more lonely and isolated than it already is. When cosmic inflation reaches a certain point, the universe might finally die in a heat death, where no new energy or heat can ever be created, and everything settles to the exact same temperature and becomes uniform dark energy. Alternatively, the universe could experience cold death if it keeps expanding forever, where everything becomes much too cold and far apart to ever support life. Ultimately, we just don't know how large the total universe is. It could be anywhere from 23 trillion light-years until it circles back in on itself, to an infinite plane of existence. But we've still got our hands full with the parts of the universe that we can examine for the time being. And that's how big the universe really is. What do you think? Is there anything we missed? Let us know in the comments. Check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.